Hey guys, how's it going? This video is going to be all about how to design a PID controller for a DC motor that does not have its own feedback system. In this case, the feedback is going to be designed very simply for speed control. Mind you, it's very simple and not very accurate. So let's start by taking a look at this circuit. This is a 12 volt battery, which is actually a very nice battery. 18 amp hour, 12 volt. Then we can keep going down into the circuit. We see the Arduino, which is basically the PID controller in this case. And we follow through by seeing a comparator, a MOSFET, then the PWM control from the Arduino, and our custom box for the DC motor along with the speed control feedback there. Then if we look back behind the battery, you'll see an oscilloscope in the background, and then all this is hooked up to my PC. Alright, let's take a look at how this circuit works. The speed is set using a potentiometer, which gives the analog input of the Arduino a value between 0 and 5 volts, where 5 volts will correspond to a high speed and the 0 volts will correspond to being stopped. Here is the PWM speed circuit. As you can see, it consists of an NPN transistor as well as a MOSFET, which controls the speed of the motor through the Arduino's PWM. You can see here as I turn the potentiometer, the value of the PWM changes. And you can see this by how thin those bars are. Those bars indicate a PWM value. The next circuit we're going to talk about is a feedback controller. Now, as you can see, there's an infrared emitter in there and an infrared phototransistor. When the light beam between the two is blocked, the output will be high. When the light beam is not blocked, the output will be low. Now, in this circuit, you'll notice that there was a comparator. This is necessary to convert your analog signal into a nice DC signal with straight edges. Here we can see the analog and DC output at high speeds and at lower oscillating speeds. So, what do all these parts boil down to? They all come together to make a nice PID controller. So in our case, the PID controller is an Arduino, the DC motor I pulled from an old printer, and the speed feedback is basically a cardboard fan that I glued onto the end of the motor. The code controls all the PD functions in the system for converting pulses into an RPM value. You can see that 4 changes in voltage occur for every rotation of the blade. A counter in the program increments a variable for every change in voltage in periods of 100 milliseconds. It then computes an RPM based on time and the counter value. So just for your information, I'm going to be posting the Arduino code on GitHub when I have the chance. Hopefully it's up by the time you get to this video. Now I'm going to show you the effect that the PD controller has on the output speed by varying the PD parameters. You can see that the actual RPM is much closer to the desired RPM. However, there are a lot of oscillations in the lower RPM range since this motor cannot operate at low speeds. This PD controller won't be able to compensate for that. Test out a couple values of your own and see how they work. Now, I hope this was helpful, and feel free to ask any questions or comment in the comment section down below.